So hello guys, welcome to this video. If you enter here the flip tank initial node, we have our wave tank, which is an ocean source node that creates a pool of particles here, as we talked about before. When we just do a simulation, we want to extrude the edges of the simulation, so we want just to create an infinite ocean surface. So you just want to extrude the edges of the simulation in order to do this. And when you extrude the edges of the simulation, you will face a problem. The fluid here, or the water near the edges, can be at a higher level, so when you extrude it, there will be a gap here, or it will not be extruded correctly. So you need to maintain a thin area here near the boundaries where the water will be maintained at the water level, and the velocities at those areas will be reduced in order to simulate the infinite ocean. Okay, so we create here this boundary layer by enabling this, and as you can see, there's a new container now inside our container, and there is a space separating these two containers. This space here can be adjusted in the X or the Y or the Z directions. So if you increase it to 2 in the X direction, there is more space now. And when the fluid enters this space here between the inner boundary and the outer boundary here, for example, here the fluid in this area will the level of the fluid in this area will be reduced to match the water level, which is this level here, when there is no collision or anything. Okay, so when we just extrude this to make an infinite ocean, water will be at the level of the extrude, or at the level of water level. Okay, so this helps us create the infinite ocean tank, which we'll be using in the render. Okay, so this is the create boundary layer. Also, I want to discuss something here. At the flip solver, the collision tab, there is a velocity scale here. If we just increase the velocity scale, it will increase the velocity of our collision. So our collision scale will be much higher if we just increase this to something like 10. Okay, and this will make our splash larger, because this scales just the velocity from the SOP, and you multiply it by a number here. If you multiply it by something like 5 or something higher than 1, the velocity of the plane will be higher, or it will simulate a higher velocity of the plane, and this will make our plane crashes more stronger. Okay, we have here this surface extrapolation. If you just decrease this, the water will be more dynamic, and the surface of the water will extrapolate more upper here, or it will extrapolate here to the in the upward direction when the plane crashes here in the water. So this will make our splash extrapolate or more dynamic if we just decrease this level, and you can try it on your own if you just do some wedges with different values. Okay, so this is for this video. We have created the boundary layer, which we can enable here in the DOP network, or we can enable it in the flat tank or the flip tank initial. Okay, this boundary layer here in the DOP network in the flip solver is just this one here is just referenced or linked to the changes, or to those parameters in the flip tank initial. Okay, so this is for this video. I hope you enjoyed this video, and wait for the next video where we will just create the splash or the explosion splash. Okay, thank you.